Hello everyone, right here today we are going to talk about the basic and the concept of bondings. So the bondings meaning for metallic bond, ionic bond and covalent bond. So first we're going to talk about metallic bond. But first, before that, we're going to know about the concept of ion. What is an ion? It's actually easy. We got atoms right here. In the last video, we talked about the electron shells. So now, what about the electron, the outermost electron? They got localized, and now they're floating. So that is metallic bond. Basically, there's meaning that there's lots of normal, and I mean those atoms just throw away their outermost shell's electron, so they becomes what we call a ion, because now without one or two or three electron they got charged. It's not natural, so we call it ionic bond. No, I mean not ionic bond, we call it ions. Yeah. So for ions is what the basic of today's video about metallic bond, ionic bond and covalent bond. After we know what is a ionic no, what is an ion? Yeah. So the metallic bond is basically those ions and those the localized electron just floating around. But for example, we got a sodium. Now we got a sodium metal. So those ions are inside them. They are just bonding around with a chemical bond. I mean, those metallic bond, ionic bond, and covalent bonds all are chemical bondings. So the metallic bond basically is just easy. It only happens on metals. For metals, like you want to use a sodium and a, for example, potassium, you want to fuse them together, then you need a metallic bond. Because metallic bond work is you got an ion and a delocalized electron. Here's the iron, here's the iron, here's the iron, and here's the iron. And the center of it, there are just some floating, moving, negative charge electrons. That's how they combine together. So yeah, that's just it. And they use electrostatic attraction, which also used in covalent bond. So now we're gonna talk about like ionic bond. Ionic bond, we need to know a basic, not only ions, also what is a cations and what is a anions. So as here you can see a periodic table, right? So periodic table here is group 1, here is group 0, which is also called noble gases. Here, from 1 to group 3, plus group 4, basically there's no ion can be made up. And so group 1 to group 3, okay, yeah, group 1 to group 3, they gotta like split out their outermost shell, because group 1 meaning that their outermost shell got 1 electron, group 2 meaning that their outermost shell got 2 electrons, to group 3 also meaning they got 3 outermost shell electrons. So they can form a what we call a cation. And for group 5 to group 7 is what it can form a anion. So after we know what is a cation and anion, so basically just they throw away or just somehow rob or get a electron not from them. So they can just like anion is a electron, they become an ion because they grab some electron floating around, boom, they grab it to them. Now they're stable because they become a object. duplex only happens for hydrogen or others that's close to helium. So most of them is octet structure. After they grab a floating electron, then they will form a anion. But cation is they don't need it. They just throw away it and they become stable because they become a octet structure. So they throw away the electron, it becomes a anion, a cation. And for anions, they grab what they throw away to stabilize them. So they become what you call an anion. After we know what is cation and what is an anion, then we can basically know how and what and the ionic bond work. For ionic bond, there is like a list. We can basically search online to know what is it. Let's just remember it, examine it. Ain't gonna lie, I fucked up for real. But ionic bond, just you need to remember the list and the table, and that's fine because it's basically just a cation throw away and anion they grab it. Just this. Just for example, it basically mostly happens for ionic compound, and usually, yes, usually, not always, but usually it's for non-metal to metal. So they need a ionic bond. Like for example, for example, when I talk about nitrogen, for example, nitrogen chloride, like calcium to chloride. Yeah, calcium to chloride is the best example. Calcium to chloride, and because calcium is a metal and chloride is not a metal, it's a non-metal substance. So they need to combine together. Usually, they need to use ionic bond. Just it. That's it. That's the concept. So we can move on to what we call covalent bond. It is also easy because they are just using also what metal use, the electrostatic attraction, to bond two things together. Usually happens in usually happens in non-metal to non-metal. So when we always see some picture of H2O, which we call water, we usually see like a Mickey Mouse, a big circle with two circles like an ear. It is covalent bond. So it is not I give a electron to you and you grab it and we stabilize together. No, it is like we share the electron shell and share the electron. And how it works is probably like yes, water is a great example. Water, hydrogen is not a non-metal, and oxygen is a non-metal too. So how it works is non-metals for oxygen, it needs two electrons stabilize it, and hydrogen it also needs one. So hydrogen it needs two, so why we call H2O. So they just combine together. They won't split. They are stable. They stable like because oxygen need two, right? So they share one to the first hydrogen atoms, and the hydrogen just like fuse together, and they share the same electron. Yes, they share the same electron to stabilize. And what about another? Like even oxygen got one hydrogen, it still need another, right? So it got another hydrogen. Yeah, that's how. It's easy. Just basically they share the electron on the outermost electron shell. So another more confusing is dative covalent bond. Instead of a standard covalent bond which they share electrons, like I give two, you also need give me two so we can stabilize together, or I give you one, you give me one, so we share it and we can stabilize together. But for dative covalent bond, it's more complex. Like even though it's easy, just for example, a ammonium. Ammonium is how? Ammonium is actually iron. The normal form is the stable form is ammonia, which is NH3. But if you want to make a ammonium ion, not ammonia, you need to get another hydrogen, which is a cation. That means it's already throw away its hydrogen atom. I mean the electrons to I don't know where, but just throw away. So now they got no negative charge, so they become a cation. And now we got a also already stable ammonia, which is NH3. So now what they do, because ammonia it share the electron to the hydrogen, three hydrogen atoms already, or I can say three hydrogen ions already. So it's got like two electron left. But for dative covalent bond, so it can donate it, like the hydrogen, it throw away its electron, it become a cation, and it's combined with the ammonia, which only left two. Originally is nitrogen outermost shell electron, and it donates the last two from nitrogen to share with hydrogen. So basically it will becomes a cation also, because hydrogen it got charge of a positive charge and ammonia got no charge, so they combine together by sharing nitrogen's outermost shell electron, so they become a ammonium ion. That's how ammonium ion form. And also we're going to give you an example of the ammonium chloride, which is not only got a ionic bond, which is weird because it's not always fixed for a non-metal to metal connection for ionic bond. But also ionic bond can happen for like ammonium ion, which is a polyatomic non-metal substance. I don't know what is that, but yes, it is. So it not only got a ionic bond, but ammonia got a extra hydrogen, so it forms ammonium ion, which also form a dative covalent bond. So in ammonium chloride, it's not only get ionic bond, it's also get dative covalent bond. So now we're going to talk about the calculation of relative and molecular mass. For this, it's actually easy, just sum of them. Like nitrogen, which is N2, you just look up for a table, because usually in exam you got a table and you can just search on it and you can see the number, the relative mass, the relative atomic mass, and you just sum up together and that's it. And it's also used the same for formula mass. They basically is almost the same thing. You can just understand it as just same thing, different name. That's it. That's the basic concept stuff for the metallic bond, ionic bond, and covalent bond. Now you know the basic, right? So we can see in next video. Thank you for learning. Got great learning. Bye.